probability that I get tails and an odd number. So what would I do with those two numbers? Same thing we did on the trees yesterday. The last couple of days. What do I do with those two numbers? Multiply them together. But if I really, from the very start of this problem, all I care about is tails and odd numbers. Is there any point in doing the rest of the tree? So, if you have two things that you want to know the probability of them both happening, as long as they're independent, as long as like one thing has nothing to do with the next one, looks like this one does, you can just multiply them together. So I can do the tree, and I can go out here and say, okay, 1/2 times 1/2 is 1/4. But the way I think of these is I just make like these little slots. There's two things that are going to happen. I'm going to find the probability of each one, and then just multiply them together. So what's the probability I get tails? 1/2. What's the probability I get an odd number? 1/2. So multiply those two together, and I get 1/4. Number 3 is real similar, so I'm going to skip to that one and then go back to 2 and 4. So 30% chance of arriving at school on time. So I got 3 straight days. What's the probability I get to school on time the first day? 0.3. What's the probability I get on time the second day? 0.3. 0.3, and you multiply the 3 slots together. And that comes out to 0.027, which I don't know if anyone did it like as fractions. But if you did it, it'd be 27 over 1,000. So I can make a tree for that too, like was that time or not? Was that time or not? Was that time or not? And just like start building it. But really, I only care about like one branch. So I'm just going to find that branch and just multiply them all together right away. And then 2 and 4 are a little bit different, but it's the same idea. If 4 people are in a race, how many ways could they finish? Well, there's 4 places. How many people could win the race? 4. Well, after someone already won the race, how many people are left that could finish in second? There's only 3. And then after 2 people have finished, there's only 2 people left that could possibly finish in third, right? And then whoever finishes in fourth, the other 3 are already done, so there's only one way, only one person left. So 4 people could win, there's only 3 people left to finish second, and you multiply those together, and you'll get 24. I don't know if you guys have ever seen factorial before, but that's what that means, is you take the number in front of the exclamation point and multiply it all the way down to 1. You don't have to know that, I'm just throwing it out there. And then 4, same thing, like I got these slots, so I got 4 pairs of shoes, I got 3 shirts, I got 5 pairs of pants, multiply them together, there's 60 different combinations I can make. That's like a super common, that was probably on your SAT somehow. Let's say that I was going to pick, so many people are here. 14 people in here. I'm going to randomly pick 2 of you. Yeah, no. Alright, this is going to make it more confusing. I don't want to do that. Let me just give out the worksheet. I'm going to try to like add them. So we're going to do the very back one together. We try to work on the front. Like up until then, I'll kind of put the answers up as you're going. And we'll figure out any questions you have as you're doing it. How do you know that if your phone is in the CAD? trig, right? It's not trig. It's not like angle. Yeah. Sine, cosine, that's what, you get 436, maybe. Some of the answers up there. Make sure you understand why they are what they are too. If you're not trying to explain. Yeah. You good? Yeah. Do the whole thing except for the back page. Front page good? You want us to? Are you good? Which one? So you small file. Like I'm gonna shoot at you, you're gonna shoot at me at the same time. What's the probability we both hit each other? I just multiply those two things together. Did you get 4 over 36?
Oh.
So I just reduced it.
Okay.
The Kobe Bryant problem, 0.83. It'd be like 0.83 times 0.83 times 0.83, 6 times. Goes to the 6th power. That's different than 6 times 0.83. Kobe Bryant was still alive when this pack was made. Is that okay? That was a little trickier because they're asking about probability it makes it not. So they give the probability it makes it, but then they're asking about probability he goes miss, 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 miss. Does that make sense why that was D? So they give you 74% of the time he makes it, but then they're saying if he makes none, so they really want you to miss. So the probability to miss is 100% minus that. That's where I got 0.26 from. And then if you miss, 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 so it's 0.26, 0.26, 0.26, 0.26. They don't write it that way, but like this part in here really means 0.26. Then times itself 4 times. Oh. But I'll put that in the second. Opposite or hypotenuse. Is that what you're talking about? Like if you said to me what sine of 45 or whatever. It's the opposite over, so on a unit circle, you go to 45 degrees, make a triangle, and sine would be the opposite. So the length of this divided by the length of this. So it's always, even though you're in a circle, it's always like the triangle length that is being used. I left it check there. Cosine of 3. So that would be like, it's negative 1. So cosine's the x value. So yeah, basically sine's the y value, cosine's the x value. So you're like down here somewhere probably if it's negative. Tangent's y over x. Sine's y. Cos is x, tan y over x. Alright, here's that page. The third one's a little tricky because it says like what's the probability that it uses both the bus and the train, but that could happen 2 ways. It could happen on the way there or on the way back. So that kind of changed a little bit, so it might help you to draw a tree on that one. So this is the first trip and this is the second trip. And if he's going to ride the bus and the train, he could go bus then train. You could also go train then bus, and so there's 2 ways out of the 9 possibilities. C is for cab. Yeah. So this is 1/9. Yeah, 1/3 times 1/3 is 1/9. 1/3 times 1/3 is 1/9. But then they both count because it just says he would ride both. It doesn't say which order. So 1/9 plus 1/9. That's how I'm getting to. Good. Down headed. Yeah. Am I going too fast? The last page, I'll put that up in a second. And then I want to do the very back page together. Alright, so the dinner one, the 1/5 chance I choose spaghetti, a 1/4 chance I choose tomato, so 1/20th, but it says what's the probability you'll end up with something other than tomato spaghetti? So I gotta do 1/20th to get 19/20th. Yeah. So specifically tomato and like tomato spaghetti is like I chose tomato and I suppose chose spaghetti. You know what I'm saying? So there's a 1 out of 20 way that would happen. And so 1 minus that's 19 out of 20. And then for the clothing one, orange hat. So there's a 1/4 chance that I pick a hat, and there's a 1/3 chance that I pick orange. And I multiply those together, and it's 1/12. Questions on any of the problems in the... These are like literally the con questions. It was printed a few years ago, so I don't know if this has changed or not on con, but hopefully this helps you on the con. And then, at the very back, we're going to make a probability tree for rolling 2 dice and adding them up. So, you might want to watch me start it, because it takes up a bunch of space. Like you gotta do 6, and then each of those have to have 6. So it's going to be fairly large. You want me to go this way? And then go this way? No, I need more room, like... Yeah, but I need more room, like... I need a hamburger, not a hot dog. Hey. Skyscraper's better. Yeah, hamburger never made sense to me. Because it's not tall, exactly. But like, people say that. Well, do whatever makes sense to you. Then turn your member. So that's like my first roll, you know? But then like each of these, I'm just gonna like run right over the directions. I roll again. How many possible combinations are there? 36, right? 6 times 6? So what I want at the end is the sum of the 2 dice, and then the probability of each sum. Like, what's the probability I roll 2 dice and get a 3 when I add them up? Or add them up and get a 5, or whatever. So I'll go through it with you. I'm just waiting for you to draw your skyscraper, hot dog, whatever you chose. So you went hot dog? But don't you need more room? Like, I didn't take up very much room this way. Yeah. I gotcha. So then next to each one, I'm going to write like what the sum of the 2 rolls would be. So like this is a 1 and then a 1, so the sum is a 2, right? So 1 plus 1 is 2 is all I was saying there. Everybody calm down. What? Oh, okay. So, and then 1 and 2 is 3, 4, 5, 6, 7. And then 2 and 1 is 3, 4, 5, 6, 7, 8. 3 and 1 is 4. 5, 6, 7, 8, 9. You don't get where we get these numbers from? I'm adding up, because I'm trying to find the sum of the 2 rolls. So like 2 plus 1 is 3. 2 plus 2 is 4. There's only one sum that you can get no matter what you roll in the first time. Like you can't get a 12 if you roll a 1 in the first time, right? What's the only thing you can get no matter what you roll in the first time? 7. Were you clapping? The people that got the answer right? So this is really going to annoy you guys then. I'm going to turn this sideways. So you have to do, we want to find the probability that the sum is 2, that the sum is 3, that the sum is 4, that the sum is 5, all the way up to 12. So how many possibilities are there? Do the multiplication thing, right? There was 6 options for the first roll times 6 options for the second roll, so there's 36 possibilities. Out of those 36 possibilities, how many ways can you get a sum of 2? Just right there. That's the only one in the whole list, right? So the probability of getting a 2 is 1 out of 36. How many ways can I get a 3? Well, I could get a 1 and then a 2, or I could get a 2 and then a 1, so it's in the list twice out of the 36 possibilities. How many ways can I get a 4? Well, I could have gone 1 and then 3, 2 and then 2, or 3 and then 1. So there's 3 ways out of the 36. See what I'm doing? Don't just keep, the pattern doesn't just keep going forever. It's kind of a pattern, but it doesn't just keep getting bigger. For a 5, there's 4 ways that can happen. For a 6, you can get a 6 here, 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 here. So there's 5 ways. And for a 7, you can get 1 from every branch. So there's 6 different ways to get a 7. But that's the biggest it gets. And then it starts like climbing back down. So like an 8 has the same probability as a 6. A 9 has the same probability as a 4. So it like works its way up and then back down. This is 5 out of 36. 4 out of 36. 3 out of 36. 2 out of 36. 1 out of 36. So I've actually seen this like in the SAT. Like not even in a stats class. Let's say like what's the probability I rolled 2 die and get 10 or more. So you have to like add up these. Certainly could be on the AP test. But it's just a pretty common thing that if you take another stats class in college, you'll for sure use this in some way. It comes up a lot. Questions on how I made it? Yeah. Yeah, we're good. We're done basically. So there's a con section that's not exactly what we just did today, so I wanted to give you some time to do that. But then if you want to work on other con or whatever. 2 more lessons. Thursday we're gonna play Deal or No Deal in class. You guys know Deal or No Deal? Where you pick the briefcases? Like yeah. Yeah, I'm not gonna have that. Sorry. And then Monday, Tuesday, Wednesday, basically a review, like all 3 of those. I won't be here Tuesday, so like Monday, Wednesday a review, and Thursday is your test, and Friday we'll check the test, so we can just like close out everything before break. Thursday next week.